Okay, for people who are joining us via YouTube or some other way that you're getting this recording, we just finished talking about introduction to who ACM AI is. You can find us at our website, or you can look at our events in the ACM newsletter. And right now we're going to be starting the first part of Demystifying AI, which is an introduction to artificial intelligence and machine learning workshop. Credit to AI for Anyone for this workshop content. It's really great stuff. So please check them out at the link right there on the slide, aiforanyone.org. Okay, so like I said, this is going to be an introduction to artificial intelligence, and I think that's just a really good place to start. If we want to start demystifying AI, we should first understand what it is we're talking about. We have 3 learning objectives, which is what is AI, how does AI learn, and how can we build a better world with AI? The first one I'm going to cover is what is AI. And to start this, we have a little activity where I'm going to present some images and I will ask you guys if you could answer in the chat, that would be great, whether or not what we're looking at is an example of artificial intelligence. So let's go to the first example. This is like a smart digital assistant. It's saying, go ahead, I'm listening on your phone, that sort of thing. In the chat, like yes or no, do you think this is artificial intelligence? And if you care to explain maybe in one sentence or so why you think it is or isn't, that'd be great. Okay, so pretend you didn't see us just flicker that slide there. That was an accident. Austin says here, I guess recognition. Well, I already gave away the answer, so I'll just go to the next slide. Yes, this is an example of artificial intelligence. And how about this image? Do you guys think this is an application of AI or not? And again, you can answer in the chat. Got a no, got another no. The first no, an exclamation mark, so really enthusiastic no there. Oh, someone says yes. Someone says no, maybe but trick question. Don't think too hard about it. It's not, I promise it's not a trick question. We're here to make things clear for you, not more tricky. I'll wait just a bit to see if there's any other answers here. For the person who said yes, actually, since we're waiting, I'm curious, maybe type like a few words in chat why you think this is an example of AI. Oh, okay. I'm sorry. Okay, you were kidding. I'm sorry. I can't read sarcasm over Zoom. That's hard. But yes, you guys got it. This is not an example of AI. It's just a microwave, nothing intelligent about it. Or nothing yet. I don't know. I don't want to offend the microwave in case there's like a robot uprising, but nothing intelligent. Okay, what about this? This is kind of like what you see on Facebook or Instagram when you post a photo. It'll ask you like, do you want to tag so-and-so? Is this an example of AI or is it not? Austin says yes, and he's special because he put 2 exclamation marks. He's really enthusiastic about his answer. I like that. Some people gave reasoning for their answers. So someone said yes, because facial recognition. I like getting reasons for answers too. That's also very nice. Does anyone else have any possible answers? Maybe someone wants to say no. Okay, I'm not getting anything. So yes, you guys are right. This is an example of artificial intelligence at work here. And for those of you who said facial recognition, that's exactly it. This is a machine that's been programmed so that it can recognize human faces and match the face to a name. So now that we've gone through some examples, let's try to get a handle on a definition for artificial intelligence, because that's a good place as any to start talking about the rest of today's topics. And what we're going to say, this is our proposed definition, is that artificial intelligence is when computer systems do things that normally need human intelligence. And to pick apart some of the words here, when we say computer systems, we mean something like your smartphone, a laptop, a desktop computer, stuff like that. And when we say human intelligence, I'm talking about things that we normally think of as only humans being able to do. So that could be having a philosophy debate, cooking, or at least I think only humans can cook. Maybe other animals can, but let's say cooking requires human intelligence. Or teaching a workshop on Zoom. I'd like to see a machine try to take my job. I'm pretty sure I alone as a human am able to do this, and no machine can do this yet. Again, apologies to any robots in the robot uprising if that ever happens. But my point is, we think about this in terms of human intelligence, which is why we call it artificial intelligence, because we want ideally a machine to mimic a human and their capabilities to do a variety of things. But there's a key word that I want to focus in on this definition here, which is normally. And what does it mean that it does things that are normally requiring human intelligence? That seems a little vague, a little ambiguous, but there's a reason for that. And it's because what happens when it becomes normal for a computer to do something? So if we go back even 50 years ago, which is like forever in computing advancement history, like think about your computer now versus computers 50 years ago. Wait, sorry, it's 2020. So sorry, go back 60 years. There we go, 60 years ago. So in 1960s, the space race was happening. We were sending people to the moon and whatnot. If you guys have seen the movie Hidden Figures, which is great, by the way, back then computers weren't what we currently call computers. It's not like a digital device. It was like people. And those people sat around and their job was to do calculations and double check math, basically, for all these astronomers and all the people at NASA. And nowadays we look at that and go, that's insane. Like, why would you just do like number crunching all day? Why not have a computer do it? And well, the answer is because it wasn't normal back then to have computers do all that work for you. They weren't really that reliable. They were pretty expensive to operate. So it wasn't normal for computers to do mathematical calculations, at least not digital computers. So instead we had human computers, but eventually it did become normal. Or if we fast forward to a more recent example, in 1997, there was this program called Deep Blue that beat the then world champion at chess, Garry Kasparov. And that was considered like, wow, people were super amazed that this was the pinnacle of artificial intelligence. But now in 2020, we look back at Deep Blue and go, that wasn't artificial intelligence. That was just a program that could calculate like all the possible moves and just pick one. So what happens is over time, as computers just do more stuff and get better at the stuff we told them to do, it becomes more normal and it doesn't really seem all that intelligent. And this is something that we're going to call the AI effect, which is when things stop being magical, because computers just get so good at the things that they're doing, it doesn't feel like magic anymore. It kind of just feels normal. Like you don't think twice when you take a photo of your phone, but if you go back even 20 years ago and told someone, hey, you're going to have a camera in your pocket that can also send emails and take phone calls, they're first going to ask you, what's an email? But then they're going to be like, wow, you can have a camera in your pocket that does all that? So yeah, this is what happens, is that things stop being magical. They kind of just become normal. Nonetheless, there are still artificial intelligence today. There are still things we consider magical. And there's a distinction between the two types of AI that we want to make. If AI is as magical as human intelligence at one specific thing, like exactly one thing, or maybe a subset of things, like 2 or 3 things, but not very many, we have what's called artificial narrow intelligence, or ANI. On the other hand, if AI is as magical as human intelligence at everything, you have artificial general intelligence. So key distinction there is being good at one thing versus being good at everything. So to really hammer this distinction home, we're going to go through a few examples again. So I will show you guys images, and in the chat, you can say whether you think it's ANI or AGI. All right, so the first image we have is the voice assistant example from earlier. Do you guys think this is ANI or AGI? And if you could, maybe one sentence explaining why it is or why it isn't. Okay. Someone in chat said ANI, maybe because it is only vocal recognition. Saying that with a grain of salt. No, you should be more confident. How do I pronounce your name? Dana? Dana? I hope I'm getting it right. But Dana says ANI. Dan, okay, cool. Just wanted to be sure. So Dana says ANI because it is only vocal recognition. Austin says, I'm going to agree with that. Okay. Oh, he's adding more. I like seeing the reasoning here, because even just understanding the sentence you're saying is like a single task. Oh, okay, no, never mind. We got some debate going on. Someone says it also generates speech though. That's true. I guess it does, yeah. Any other thoughts on whether this is ANI or AGI? Okay, Austin's responding. I feel like I'm like a fight commentator right now. Like, you know, when they have like someone commentating like a wrestling match, like that's what I'm doing. I'm just like echoing exactly what's going on in chat. But I like this, so this is good. Austin says, but all the stuff it says is a response to what you said, and the response is always the same, at least when I talk to Siri. Okay, yeah, that's totally a reasonable argument. I'm going to go ahead though and say that this is ANI because it is only good at a subset of tasks. You're right that it has to generate speech as well, but those could all be clustered within a narrow subset of like vocal related activity. You couldn't reasonably ask Google Assistant or Siri to like play chess or cook for you, for example. Like those are very distinct tasks, whereas generating speech and understanding speech, not so too distantly related. So we're going to call it artificial narrow intelligence. Okay, and then this example, fictional character, but I think it's still a good one. ANI or AGI? I should clarify that this is Wally, by the way. I don't know if everyone knows. So just just so everyone knows who this is Wally. You can look him up if you don't know. AGI, Wally got emotions. Yeah, AGI with an exclamation point. AGI because it's able to do certain tasks and communicate. Yeah, so Wally is an example of what we would call AGI because he can do lots of things, not just one thing. I'm going to go through the rest of these examples a bit quicker now since I think we're getting the hang of what's ANI versus AGI. Self-driving car. Does someone care to say whether ANI versus AGI? Okay, Austin says ANI. And yeah, that's exactly it. A self-driving car just drives cars. It's not like it can do, again, it can't play chess. It can't solve differential equations. It just drives a car. It's artificial narrow intelligence. And then the facial recognition example from earlier, ANI or AGI? ANI as well. Yeah, totally. ANI because it just tags people in pictures. Yep, you guys got it. And then the last one, ANI or AGI? And again, if you somehow don't know the reference, this is the Terminator. He is the robot upright. Yeah, he is. AGI, yes. This is artificial general intelligence. So to quickly recap some of the differences between ANI and AGI and how they might be similar, ANI is good at one thing, whereas AGI is good at pretty much everything a human can do. Both types of artificial intelligence learn from examples. AGI can transfer the skills it learns to new areas. So it, again, is a general intelligence, meaning what it learns in one area might be applicable to another area, and it can figure that out. And ANI exists today, but AGI does not exist and may never exist. And that should have clued you into that, because both of the examples of AGI we showed were for movies. They're not quite real yet. And now we're going to talk about how does AI learn with an example of a computer program. So as soon as I switch the slide over, you guys could probably immediately tell that the image on this slide is of a tiger. But how can we get a computer program to understand that what we're looking at is indeed a tiger? Let's say we write a program and we call it, is this a tiger? There's some features we might look at, like does it have 4 legs? Yes, it does. Does it have a tail? Yep. Does it have 2 ears that stick up? Yeah, looks like it. Does it have whiskers? Does it have black and orange stripes? And if we look at these questions, we could answer yes for all of them for this image right here. So our answer for our computer program will be like, yes, it is a tiger. But let's see how this might not work. Let's run the same program on this picture of what you guys can tell is a cat. Does it have 4 legs? Yep, it has 4 legs. Does it have a tail? Sure does. Does it have 2 ears that stick up? Even more so than the tiger, I would say. I would say that this cat's ears are like really standing up. Does it have whiskers? Certainly it does. And does it have black and orange stripes? Some of you might say that these are actually black dots, but let's say that they're stripes. There's stripes on the tail at least. So it does have black and orange stripes. And the computer program will go, yes, it is a tiger. But you and I both know that if we look at this image, we go, that's not a tiger, that's just a cat. So now I'm going to hand it off to Kai, because we're going to play a game to try to figure out how a machine learning model or how artificial intelligence learns.
Okay, sorry, I had to unmute myself first. Okay, so just to go over the directions of the game, so just so you guys get an idea. Okay, so there's going to be 3 types of digikiki, which is just going to be different types of shapes in a make-believe world. So they're going to be called Yoda clouds, fluffsters, and skizzles. And what we're going to try to do is I'm going to show you a series of images, and I want you guys in the chat to just type Y, F, or S, because typing out the whole word would be insane. So we're just going to try to understand how an AI learns. So let's start. So first we have this shape, and you might be thinking, I have no idea what these shapes look like, so how the heck am I supposed to guess? But it's all about it's all part of the process, so just trust me. So just go ahead and type Y, F, or S in the chat to understand what's going on. Okay, so we got a good mix of everything. So now I'm gonna go ahead and tell you that this is actually a Yoda cloud. If it loads, yeah, so this is a Yoda cloud. And then we're going to keep doing this. So it's kind of going to be like a speed run. So I hopefully you'll learn what each type of shape is through more examples. So what do you guys think this shape is? Okay, again, a good mix. So I'm going to go ahead and tell you that this is a skizzle. And what do you guys think about this shape? Okay, so pretty much all of you said it is a skizzle. So I'm starting to see that you guys are seeing the pattern, which is good. Okay, so next, this one. All right, fluffster, just because we haven't seen one, that's a good guess, but I will tell you it is a Yoda cloud. How about this one? Okay, yeah, you can see that it's very different from the other two. So you guys are guessing fluffster. So good job. It is a fluffster. So hopefully you guys have a better idea of what each type of shape is, and you're better able to guess and categorize each one. So what do you guys think about this one? Okay, skizzle, good job, good job. What about this one? All right. I see a Yoda cloud in there. Lots of flusters. Okay, it is a fluster. And this one, this is our second to last one. Right, flusters. Good job, good job. And then last but not least, oh, I just gave it away, but it is a Yoda cloud, my bad. But hopefully you guys were able to see the different patterns between the shapes. So in the beginning, you guys could probably tell you had no idea what each type of shape was because I didn't tell you anything about anything. So it must have been really hard, but once I gave you more examples and told you what each shape was, it was easier to pick up patterns and get the criteria of what each shape was. So that's kind of similar to how AI learns. You know, we have to train the AI with lots of data and label the data so that it understands the patterns and is able to perform well by itself. So let's look at a different scenario. So say somebody asks you to describe Mark Wahlberg and Matt Damon to them when they haven't seen them. And this might be a little more difficult than explaining the differences between the Digikiki, just because, you know, there's more clear-cut patterns in the Digikiki. As the Skizzles, they were more like triangularly shaped, and the Fluffsters had a red outline, which is not the case with explaining these two celebrities. You know, it's harder to explain facial features. So the whole point I'm trying to get across is that describing complicated rules to a computer is hard, and figuring out what the rules should be in the first place ourselves can also be hard. Like with the example of the Digikiki, it was much more simple to recognize a pattern and verbalize that. But in the case with the describing celebrities, it might have been more hard. So this brings up the point, how does AI learn? So AI learns through examples and lots of repetition. That's exactly how we learn too. So in the beginning, we had no idea what was going on, but through examples and me telling you what the label data was, you're able to make your own patterns. So let's say, let's move on to the next slide. So what does an intelligent computer program entail? So if we go back to our program, which identified whether the image was of a tiger or not, to make sure that we would have to give it lots of examples and lots of repetition. So we would give it lots of examples of images that are of tigers, lots of images that are not of tigers, and also lots of edge cases, which would be images that look like tigers but are not, like the cat and the lion and the cheetah. So by giving all these different variety of images, their computer program would better be able to differentiate between what is a tiger and what is just a cat. Right. Oops. And now let's talk about some issues with data. So what if some of the data was wrong? What if we gave our AI wrong data to train with? So in the example of our Digikiki, so if we looked at our Yoda clouds category, the last two are actually Skizzles. And if we look in our Skizzles category, the last two are actually Fluffsters. So what would happen if this was the case? So if we look at this in a real life setting, let's say we have an autonomous vehicle and we're trying to make the autonomous vehicle learn the difference between people and lampposts. So what do you guys think would be wrong with mislabeling the data or having wrong data? So let's say if we labeled lampposts as people and people as lampposts. So what would be some problems with that? Go ahead and just type in the chat what you think would happen. Exactly. The car would start hitting people when it tries to dodge a lamppost. That's exactly what would happen. So that would be very dangerous and a big no-no. So we have to make sure our data is correct. So another issue that we would have to consider is what if we only had a few examples of Yoda clouds? So when we were playing the game, imagine I only gave you one example of the Yoda cloud. It would have been way more difficult to identify Yoda clouds if they came up later on. So in a real life setting, if we applied this to like Facebook's auto tag AI, and the AI, let's say the AI only trained with examples of faces of men and no examples of faces of women. So a big problem with that would be that the Facebook AI would not be able to recognize women. It would only be able to recognize men, just like how we would only be able to recognize fluffsters and skizzles and not Yoda clouds. So the big thing with both those points is that AI is only as good as the data it learns from. If your data is flawed, then the AI will also be flawed. And in terms of building an AI, engineers do spend most of their time making sure to collect data and filtering out the good data from the bad data so that they have a good variety and that the program that they use the data to train performs like it is intended to perform. So last thing we're going to look at is how can we build a better world with AI? So to do that, let's look at examples of AI that are being built today. So first, we have this GIF of a self-driving truck. I'm sorry if you say GIF, I say GIF. So here's a GIF of a self-driving truck, and we have mentioned autonomous vehicles with the smart car, like Jason said. So hopefully, you know a little bit about that. And then next, we have this, oh yeah, there's this video of this robot that was built for military purposes, and it can be used as an autonomous weapon. So it's going to be doing some Olympic level gymnastics. Yeah, so hopefully you saw that. Sorry, the video was a little choppy. But so these are two very different applications of AI, right? So we have self-driving trucks and autonomous weapons. You might have mixed opinions about both of these. So self-driving vehicles, you might see a future with them. You might see them as convenient and that they would be really cool to have. And then autonomous weapons, you might be more wary. You might be like, you know, what are the ethics behind that? Is that something we really want in the future, to have a program be able to identify a target and eliminate it using weapons? So those are very different applications. But if we look at those a little deeper, we can actually see that they are not completely different. So both self-driving trucks and autonomous weapons actually use the same underlying type of AI. They both have image recognition and spatial awareness. So image recognition is basically, like we talked about, a self-driving car being able to identify what is a lamppost and what is a person. And spatial awareness is basically a vehicle being able to know its location relative to other objects. So knowing that there's a car next to it or behind it, and knowing that there's a bicyclist on the other side. So they do both have the same underlying technology, which essentially means that we are not able to improve one without also improving the other. So it's important that we keep those connections in mind. So since AI has, you know, we saw the negatives and positives of the AI that was used for self-driving trucks and autonomous vehicles, or autonomous weapons, my bad. So it's up to us to promote positive uses of AI in society so that nobody gets left behind. It is all of our responsibility to make sure that everyone is included in the conversation of setting limits to using AI, and we have to make sure that we weigh the pros and cons before putting it into use. So just a little, hold on, I think my mouse is like stuck. Okay, there we go. Just a little recap. So we learned about what is AI. We learned AI is when computers use skills that normally need human intelligence. And we talked about ANI and AGI. So hopefully you guys understood the difference, that ANI is very specific and AGI, as the term is pretty self-explanatory. So our artificial general intelligence is pretty broad. And we also learned about how does AI learn. So with the game, hopefully you got the idea that AI learns through repetition and lots of examples, and it needs good data to make sure that it performs how it is intended to perform. And we also learned how can we build a better world with AI, which is to make sure that we understand that AI is a tool that can create positive and negative outcomes, and we have to weigh all the implications before putting it into use. So a huge thanks to AI for Anyone for providing us with this curriculum for this workshop. Please do fill out their survey and visit their website to just understand what type of work they do and their mission. And I will put those in the chat right now. And also, so our ACM members out there, please log on to your member portal and enter the code MAGIC to earn points for coming to today's event. And if you're not an ACM member, please make an account and come to ACM events to earn points. And I think at the end of the quarter, the top points earners get cool prizes. So stay tuned for that. And also, please fill out our feedback form, to tell us what you liked, what you didn't like, and what we can do to improve our events in the future. And we will send that in the chat later as well. And do not worry if you didn't get this slide down, because it's going to be coming up quite a lot throughout our presentation today. So do not worry about that. And I think we're like 2 minutes ahead of schedule, but that just means a little longer. A little longer of a break. So go bother your family, take a quick power nap, but we'll be back shortly with more exciting events. Thank you.